Good morning, everyone, and thanks for the intro, James. As said, my name is Markus, and today I would like to talk a bit about pragmatic semantics at web scale. But before we get started, I think it makes sense to bring to mind how big the web actually is, because that influenced a lot of the design decisions behind the technologies that I'm going to talk about today. So currently, the web consists of roughly 2 billion websites, and they are made up of roughly 130 trillion web pages, individual web pages. So those are huge numbers, and they're quite conservative estimates, by the way. But regardless what the numbers are precisely, I think it's fair to summarize them by saying that we are really drowning in data these days. So it's not like in the past where there was a scarcity of data, where it was really hard to find data, to get access to that data. Nowadays, we have the complete opposite problem in a lot of cases. There's so much data out there that it becomes increasingly difficult to process that data. So even though we have all of that data there, we're still kind of starving for information. And what I mean by that is that raw data by itself is not very useful in a lot of cases. It's still very difficult to extract actionable insights from that data, to make decisions based on that data, etc., etc. Now, there are obviously various reasons for that, but I think the simplest way to summarize it is by boiling it down to two main issues. And the first one is that most of the data out there is still only available in an unstructured form. And we're still very bad at processing unstructured data. So we made huge progress in the last couple of years with all of that, progress in machine learning, for instance. We're really good at processing images or speech, for instance. But mostly what we do there is just bringing that data in a structured form before we process it further. So we are actually not really working with structured data. We just built some tools to bring it into a structured form. And the other factor, the other problem, which I think is even bigger or more fundamental, is that even if we have highly structured data, the semantics are normally just implicitly there. So they're not well-defined semantics. What this in practice means is that usually there is a developer that needs to go and read some documentation, try to understand what someone else wrote there, and then kind of translate his understanding into some special code that is able to understand the data, that is able to process that data in the way it was intended. And sometimes that doesn't really work out. So there are simple things like unit conversions which cause rockets to explode, for instance. Effectively, what all of this leads to is that data integration is still mostly a manual effort. And that has all sorts of problems, like rockets explode, your clients break, you end up with very brittle systems. And this is, by the way, still a largely unsolved problem. There's a multi-billion-dollar industry behind it, but we're kind of not getting much closer to solving this problem for good. And this was actually a problem that the Semantic Web promised to solve basically almost 20 years ago. As we all know, that didn't turn out quite well. So this article, for instance, is probably the most famous article. It was published in the Scientific American in May 2001 by Tim Berners-Lee, who, by the way, happens to be the inventor of the World Wide Web. So in there, he and a couple of his colleagues describes the vision of the Semantic Web. So and it's a really compelling vision. Like they have one use case, for instance, where they describe a scenario where a user, for instance, wants to go for vacation. So he would just tell his smart agent that he's, for instance, interested in going to a vacation where there's a beach, it's warm, and he would at maximum spend £2,000 or something. And then that smart agent would go on behalf of the user, crawl the web, compare offers, compile packages, and if the user granted access to the credit card information of the user, even go as far as booking all the things. So the smart agent would effectively come back with a nice vacation package, everything on calendar, and just hand it over to the user. And the user wouldn't really need to do all of that work himself. Now, this was a really powerful article in a way. It inspired a whole lot of researchers, mainly in academia, but also in research institutes and in industry, to build a whole semantic web technology stacks over the years. So they really there was lots of investments, lots of research programs, and they built technology on top of technology. And they were really powerful technologies at times. They were really expressive, powerful technologies, but the problem was that they were kind of focusing too much on the technical aspect, in my opinion. They were way too often focusing on theoretical pureness or almost mathematical precision instead of focusing on more like practical problems that people were facing with at the moment. So I think in hindsight, it's fair to say that this article that Tim Berners-Lee published back then did actually more harm than it did good. Like, it caused the community to drift off into areas like reasoning, artificial intelligence, and knowledge representation. And remember, this was 20 years ago, so like machine learning was not a thing back then. Like, it's certainly not the hype it is currently. And this led to all those technologies which kind of, were powerful but missed the point. They were not solving the problems people were struggling with at that time. So effectively, the whole thing was widely disliked. People ignored those technologies. Some of them even like actively hated them. I think the way I like to summarize it is in a lot of cases, people develop something I like to call semophobia. So they're actively afraid of even just reading about those technologies, even though in some cases they would be able to solve their problems. So, and that took quite a while. Like the Semantic Web was declared dead several times. I think it's fair to say that it is kind of dead. But it took, like after a decade later, basically, Tim Berners-Lee had a genius idea, and it was a quite simple idea. And basically what he did is he rebranded the whole thing. So instead of calling it Semantic Web, he now called it linked data. And I think, even though this sounds simple, and you may laugh about it, but I think this had a fundamental shift. This caused a fundamental shift in the community, because it brought the focus back on what's actually important. And that's the data and the fact that that data is interlinked. So, like roughly 10 years ago, Tim Berners-Lee and like other people started to urge governments to open up their data sources. Like they forgot about all that dogmatism that was there before about publishing it in RDF, XML, or any other semantic web technologies. They just asked people to put the data out there, like in whatever format it was available. And then as soon as the data is out there, you can start processing it and making it more useful. And normally the way to make data more useful is to integrate it with other data sources. And that's the links and linked data. That's exactly what made the web successful in the first place. It's those links between documents. Because normally integrated data is much, much more valuable than siloed data. And so going back to our famous semantic web technology stack, what the community realized back then is that, well, first of all, we don't need a separate technology stack. Like the semantic web should not replace the existing web. It should instead extend the existing web. Like the web is basically the most successful information system humankind has ever built. So throwing that away is like a huge waste. It's much, much better to build on top of it. Just building some technologies that allow to extend the web to become semantic web in a sense. And the other key realization back then was that, well, maybe all of those technologies, they aren't actually needed. Like, if you actually want to solve a problem that people are struggling with, in a lot of cases, you can get by just using a handful of those technologies. And that obviously simplifies the problem a lot. And some of those technologies didn't even exist back then. So the effect of this is that a lot of that previous complexity could basically be forgotten. And you could kind of start over and do it right the second time, in a sense. So you ended up with a much, much simpler technology stack, which helped a lot with adoption. And one of the things that we worked on at the time was JSON-LD. So we tried to find a data format which is really like kind of easy to understand for the everyday developer. Like in the best case, they would kind of already feel like they are already familiar with it when they start looking at it. And I think it worked out relatively well with JSON-LD. Like all web APIs, etc. these days, they're based on JSON, and JSON-LD just adds a little bit of additional data on top of completely idiomatic JSON documents in the normal case. So effectively, you take a JSON document, put an additional layer of data on top of it, like sort of a description, and that makes the data understandable to a machine. And then you can automate and get much better processing for a lot of things. So I think this is still kind of abstract, even though I really like the picture. So let me try to explain it a bit better based on an example. So let's assume you're a music band. So you obviously have fans, you play concerts, and you want your fans to know about it. So what you do these days is you would put your events up on a website. Now this works well for your hardcore fans, like they're fine coming and checking your website every now and then. They may even subscribe to your newsletter, but like your hardcore fans are normally not enough to fill like a stadium or something. So you want more people to know about it. Now on the web, normally people find out about things by searching for it, but this is a use case which is, for instance, very difficult for a search engine. Like it's obviously a search engine could answer a query like Preacher Son events or Preacher Son gigs, and it would point you to that website. But if you would ask for something like events in Dublin, for instance, because the first example here, that would already be extremely tricky. And the more precise you make the search request, the more difficult it becomes. So for instance, if you were looking for something for November 6th, it would be extremely difficult for a search engine. In fact, like it's not even clear which year it is. Like that information is up there. And yes, it's an old screenshot. So all of this means that you're kind of limited in what you can do with this data. So the way JSON-LD solves this is it solves it by allowing people to easily make that data available in a structured form with well-defined semantics. So effectively what the Preacher Son did in this case here is they embedded a block of JSON-LD into their website, directly into their website. If you're familiar with JSON, I think this should look quite familiar, especially if you ignore the keywords with the @ character at the beginning. Those are JSON-LD keywords. The rest is like basically a JSON document. Its name, Preacher Son at the Workman's Club, has a start date, which obviously makes sense for a concert. There's a location of the concert, the geo coordinates, so you know exactly where it is, etc., etc. What JSON-LD does here is it adds that little bit of additional data to that document to make it interpretable by a machine. So all of these other strings here that you see, like you as a human, especially if you have the context that I gave you before, understand immediately what they're supposed to mean. Like you know what the start date, location, etc. means. But if you wouldn't speak English, that would be quite tricky. And the machine doesn't speak English. So it's just some characters there for the machine. So the way to get this to be understood by a machine is to replace those ambiguous string tokens, like those property names, with something unambiguous. So you would like to have globally valid identifiers that you can use to refer to certain concepts. And the way JSON-LD does this is by linking those property names, such as name, to schema.org names, so to full URLs. Those are the identifiers that are commonly used on the web. And the beauty of all of this, of using URLs, is that, well, it just works like the web. So if you encounter an identifier which you don't understand, which you don't know anything about it, well, you just go and look it up. Like you can just follow that hyperlink. So for instance, if we wouldn't know what a music event is, we could just go to schema.org/music event and look the definition of a music event up. And we would get back a definition like this one here. So we would see, well, an event is a specialized type. Music event is a specialized type of event. It has a lot of properties. These are the types that the values of those properties have to take. There's a description for each of the properties, etc., etc. So what schema.org effectively is it is a shared vocabulary. So it allows people and like machines kind of to speak in the same language. They will immediately understand each other if they use the same vocabulary. And the thing that makes schema.org so interesting is that it is widely understood. It was created by the 4 major search engine providers originally, but nowadays it is understood by hundreds or thousands of applications out there. So whenever you express your data with JSON-LD and schema.org, you don't have to think about those data integrations anymore. Like your data will be immediately understood by those third parties. And as soon as you have an understanding, a semantic understanding of the data, you can do really interesting things. So for instance, in Google, we can give you much more tailored, much more precise search results. So for instance, going back to the example we had before, the Preacher Sons, we can now give you like a list of their upcoming events, like really show you the date right there on the search page. And if a user clicks on one of them, we can give you a nice summary of that event. Like we know where the venue is, so we can show you a map. We have the GPS coordinates. We can even integrate that with other data sources, like the Workman's Club down here, that there was no link to the venue before in that data. But since we have the GPS coordinates and the name, we can infer that this is probably the venue there, which we also know that it has a website, so we can link there directly as well. And obviously we'll link back to the website as well. So I think what all of this led to is that it, for the first time ever, aligned all the incentives on the semantic web, on linked data properly. Like what this effectively is it is a huge ecosystem. And for ecosystems to work, it is important that everyone that participates in the ecosystem benefits from it. So in this case here, the Preacher's Son, they get their data out there, like they get it discovered. Effectively, it helps them to get more people to show up at their concerts. Google is able to provide much better user experiences, much better results to end users, and end users obviously benefit from those results. So it's kind of a virtual cycle where everyone benefits, and this helped a lot with the adoption of all of those technologies. In fact, we see that today, roughly 1 out of 3 websites out there are marked up in such a way. So saying that semantic web is kind of not entirely true anymore. It's now at the same scale as the web, like on the same order of magnitude as the web itself. So that's a huge amount of data that's out there in a highly structured form, with well-defined semantics. And like I think the use case illustrated the power of that quite nicely. But there are some use cases which we, as we designed those technologies, couldn't think of at the time. Like we had web APIs and stuff like search in mind, but people were really creative with those. And just to give you one more example, which I quite like, is what the Gmail team did. So the Gmail team realized that, well, they process emails. That's relatively dumb. Like it kind of works the same for 30 years or more by now. But if you would have an understanding of what's in the email, you could do much smarter things. Like for instance, what they did is they allowed airlines to again embed a little block of JSON-LD into their emails. So whenever you book a flight now, Gmail will understand that you booked a flight. It will know what flight exactly you booked. And it can show you a nice summary of that on top of your email. So you don't need to go through all your email. You will have an information of the flight on top of your email. The advantage of that is that the email is static, so once you receive it, it doesn't change anymore. But the information about your flight likely changes. So Gmail can now give you up-to-date flight information on top of your old flight booking confirmation email. So it can show you if the flight was delayed or canceled. It can also give you a direct link to the check-in site. And since Google is primarily a search engine, it can obviously also index that data. So if you're signed in, you can now start searching for your own upcoming flights. And that's surprisingly useful if you travel a lot. But it doesn't have to end there. Like now that it has that information, it can take that and push it to your mobile phone. And if the airline supports it, it can even go as far as downloading a boarding pass for you. So effectively, the only thing that you need to do yourself is, apart from booking the flight, is walking up to the gate and swiping your barcode. And I think this illustrates really nicely how much more powerful applications you can build if you have an actual understanding of the data, if you know what the data is about. And I think with all the recent work on like the Google Assistant, etc., we're now really very close to finally realizing that vision of the semantic web that has been set out like more than 20 years ago and for a long time seemed to be completely dead. I think we are now really at the state where we can make that a reality. So some of the use cases already work quite nicely. Like we can, for instance, just by talking to the assistant, check what movies are playing in the cinema and then get a ticket without ever having to browse the web or trying to find information ourselves. All of that is much more convenient this way. And with that, I would like to thank you for your attention.